Metaverse has taken the world with a storm. Metaverse is becoming popular day by day, or I should say, minute by minute. Everybody wants to hop onto the train of Metaverse or maybe some other virtual reality worlds that may come in the near future. But why not hop inside the world of this virtual reality with a game of your own? Today, we are going to show you how you can set up your Oculus Quest 2 VR headset with Unity and how you can start building applications directly inside your Oculus Quest 2. We are also going to show you how to work around in Unity and develop a very basic game of our own. Remember, this video contains a lot of parts, so make sure to check out the timeline given in the description box and jump to the part that you want to see. So let's get started. Well, first things first, we need to download Unity Hub. We can download Unity by going over to their website and clicking on this button that says download for Windows. If you're running some other operating system, then you have to scroll down and download Unity Hub for your operating system by clicking on these links right here. Inside Unity, you need to install the editor. To install the editor, go over to the Installs tab and click on Install Editor. Remember, you can download any version that you want. You can even download the new versions that are not stable, and you can even download pre-releases. But I personally recommend you to download the versions that have long-term support, as they are the most stable versions out there. If you're trying to build an application that would run on the Oculus Quest 2 as a standalone application, that means it would not require a PC to be tethered with the Oculus Quest 2, then you need to make sure that you check these boxes that says Android build support and then install the editor. I'm not going to install the editor right now because I already have an editor installed on my PC. Next up, you're going to head over inside the projects tab and you're going to create a new project. Here you can see that there are a lot of templates available. You can choose any template that you want. As we are going to be developing a VR application or we are going to be working with a VR device, so we can even choose this template that says VR. But I personally prefer to use a 3D template and working our way with that. But to demonstrate a simple screen, we're going to choose this option that says Unity Render Pipeline. The URP stands for Unity Render Pipeline. Name your project and press on Create Project. Once the template is fully loaded, you can see a bunch of options on the screen. This is your God mode. You can view your scene, edit elements, and move stuff around in this screen. While this is the game mode. This is what the player or the device that runs this application would see. This is the hierarchy. It contains a list of all the elements inside the scene. While this is the explorer, which would contain all the elements or all the files that are included in your project. You can work around in Unity or in this screen by right clicking on your mouse button and moving the camera around. You can also use the WASD keys to move forward, backward, right, and left. To pan the camera, you have to click the middle mouse button and move your mouse. Now, if we talk about the objects in this scene, well, you can actually move the object in the scene by clicking on the W key, or you can rescale it by clicking on the R key. You can rotate an object by clicking on the E key. This way, you can work around with objects within the scene. Next up, we're going to install the XR Package Manager. Well, to install any package or any asset in the Unity, you need to go to the Package Manager. You can access the Package Manager by clicking on this Windows tab and going inside the Package Manager option. To install the XR Package Manager, you need to click on this option that says In Project and change it to Unity Registry. And from the Unity Registry, you're going to scroll all the way to the bottom and click on this option that says XR Plugin Management and then click on Install. This XR Plugin Management manages and offers help with loading, initializing, settings, and build support for almost all virtual reality devices, including the Oculus, the HTC Vive, and the Rift. Now that we have set up our Unity for the Oculus Quest 2 or any other virtual reality device, Now that we have installed the XR plugin management, we now need to configure our Oculus with our PC. For that, open up the Oculus software and make sure that your Oculus or Oculus Quest 2 is connected to the PC using the link cable. I have already linked my Oculus Quest 2 with my PC, but I'm going to show you the steps by which you can set up your Oculus Quest 2 with your PC. Go to Devices, click on Add Headset, and then just follow along with the process. And make sure that you're using the link cable because the Air Link is still in beta versions. That means that it is not that much stable. Just connect your headset and click on continue. But again, as I've already linked my Oculus Quest 2 with my PC, I don't need to do the following steps. Now that we have linked our Oculus Quest 2 with our PC, we need to make sure that the option unknown sources is turned on. We can do that by going into the settings option and then heading over to the generals tab and clicking on this option that says unknown sources. What this does is that it allows Unity to build applications directly inside the Oculus Quest 2. Okay, so the next step is to turn on the developers mode from your mobile device. On your mobile device, open up the Oculus Quest app and head on over to the devices tab. And from here, you're going to head inside the option that says developers mode. Just make sure that this option right here is checked or turned on. This will allow Unity to run applications during the development process as a developer app. Okay. So we have installed the Unity, we have linked our device, we have even allowed developers mode and unknown sources, and we have installed the XR package manager. But there is still one thing left, and that is the XR Interaction Toolkit. The XR Interaction Toolkit package is a high level, component based interaction system, and unlike the previous interaction packages, XR Interaction Toolkit provides a single input package for almost all VR headsets. This means that you can map the Oculus controllers, the Oculus Rift controllers, the HTC Vive controllers, and other VR headset controllers under the same key mapping. To install the XR Interaction Toolkit, from the package manager, click on this gear icon and click on the Advanced Project Settings. From here, click on this option that says Enable Preview Package. Now go back to the package manager and you'll see a package called XR Interaction Toolkit. Remember, this package is still under preview, which means that it is not fully stable, but still, it is the choice of hundreds of VR developers. So just click on the install button and install the XR Interaction Toolkit. While it installs, the term XR means AR plus VR, or it is commonly known as mixed reality. So in this tutorial, you will hear the words and the names XR a lot, which would stand for mixed reality. After the package has installed, click on the Yes button to restart the Unity application. And just wait for Unity to restart. After the restart, just scroll down to the XR Interaction Toolkit, click on Samples, and install or import the default input actions. This would import all the key maps that are available in the repository. From the Explorer, head inside the XR Interaction Toolkit folder and click on each one of these input interactions and click Add to the default key maps. This allows you to map keys from different headsets. Now that the interaction with the controllers is done, we can move on to the next process, which is building our application. Well, to run the application on your Oculus Quest, make sure that the Oculus Quest is turned on, linked to your PC, and is inside the Oculus Link mode. In your headset, open up the options and head over to settings and click on this option that says Oculus Link. Now you're inside the third mode. While in this mode, you can develop your applications with Unity. Now coming back to the Unity, we're going to head inside the project setting by going over to edit and then clicking on project settings. In here, you're going to head over to the XR plugin management. Now you're going to select for Windows or for PC, you're going to select Oculus. You can even click on the OpenXR option if you want to develop your applications for other open source VR headsets. And then you're going to head over to the Android tab and you're going to select Oculus as well. Close the project manager and click on the file option and select build settings. As I want to develop my application for the Android system or a standalone app for the VR headset, that is why I'm going to head over to the Android tab. From the Android tab, I'm going to choose my device, which is the Oculus Quest 2. And if you do not see this option which says build and run, you need to switch platform. So click on switch platform. Once that is done, you can click on this option that say build or build and run to create our application and install it directly into the Oculus Quest 2. But we are not going to do exactly that right now. We'll do this at the end of the video when we have developed our application. You can run your application on the Oculus Quest 2 by simply clicking on this option. But remember, you need to be in the Oculus Link mode on your VR headset. As you can see, I am getting the output in my Oculus Quest 2, but I'm not actually able to move the camera with my head's movement. That is because we are not using the XR camera. To fix that problem, stop the executing and delete the main camera from the hierarchy. Here, create a new camera by clicking on this option that says XR origin. Set the position of this XR origin to 0, 0, 0 and move it inside the scene. Now try running the program once again. Now as you can see, even on Unity that I am able to move my head around or my camera around the scene. So that is how you can work in Unity with your Oculus Quest 2. Next up, we are going to learn how to create a simple game in Unity for the Oculus Quest 2. For that, we're going to start from scratch and we're going to create a new 3D template. And in here, we're going to import the same packages, the XR interaction toolkit and the XR plugin management, just like we did in this scene. So we're going to just time lapse it and you can just sit back and enjoy. Okay, I have my new project set up. I have installed the packages XR plugin manager and the XR interaction toolkit. I have even set up my build settings for Oculus Quest or Oculus Quest 2 as well. So in the hierarchy, I don't need the directional light or the main camera and I'm going to delete them both. Inside here, I'm going to build a new camera by going over to XR tab and clicking on the XR origin. Make sure to position it at 0, 0, 0. So we are going to try to replicate the game Beat Saber. As you know, Beat Saber is one of the most popular game on Oculus Quest and on other VR headsets as well. So we need a platform to stand on, we need some cubes that will be flying towards us, and we need two lightsabers which we will use to destroy those cubes. So we are going to do all of those things. So just stay tuned and keep following the tutorial. So just like in Beat Saber, there is a platform under the player. So we're going to create a platform by clicking on the hierarchy, right clicking on the hierarchy actually, and going to the 3D objects and selecting a cube. We are going to give it some dimensions. You can give the same dimensions or you can even customize your own dimensions. It's really up to your creativity. And then I'm going to move it a little below the camera. Now I'm going to head over to the assets folder in the Explorer and create some materials. Materials are used to define some colors or textures on a 3D object. So just right click on the Explorer, click on create and click on material. So I'm going to name this as black. And then we are going to change its color to black as well. Now, to place the material texture onto the cube, just drag it onto the cube. Now you know in Beat Saber there are two platforms, one for the player to stand on and the other one from which the cubes are coming. But to keep it on a very basic level, we're going to just create a single platform and we are going to lengthen it on one axis and rearrange it. And we have our basic scene set up. But there is a slight problem. We don't want this environment, the sunset or whatever that sky is, in our scene. So what we are going to do is that we are going to duplicate this cube and we're going to create it as a room. Give it some dimensions like 50, 50 or 300 or maybe like 100. Now as you can see, all the platform and the camera is enclosed inside this cube. But we cannot see the lightning inside the cube. To change that effect, click on the black material and change the shader from standard to particles and standard surface. Now, click on this option that says two-sided. As you can see, as soon as I clicked on this two-sided option, my camera was able to see inside the room. Okay, next up, we need two sabers. We need two swords or sabers, whatever you want to call them. To create those, we need to first interact the two controllers with our camera and then give them a model of sabers. So let's first create the two controllers by clicking this XR origin and opening up the camera offset and creating its child as an empty game object. I'm going to call it the left hand controller. I'm going to duplicate it and call it the right hand controller. I'm going to select both of them at the same time and then I'm going to add a component called the XR controller. But remember, as I'm only working with Oculus Quest 2, I'm selecting the device-based controller. If I'm using the XR interaction toolkit to develop an application for all or almost all of the VR headsets, I would choose the option which says action-based. But for Oculus, it's device-based. For the left hand controller, I'm going to change the controller node to left hand. And similarly, for the right hand, I would change it to right hand. Now we need the two sabers. So we can create a saber by actually creating an empty game object, calling it the red saber or left saber. Let's call it the red saber. And inside the red saber, I'm going to create a new cube. I'm going to call it the left, or just leave it as cube. I'm going to resize it as some random small value. Let's just say 0, or that's too big. For the z-axis, I'm going to keep the value of 1. That will be the length of my ray as well. So make sure to keep it 1 or the value which will determine the length of the sword. Now that I have a red saber, I can simply duplicate it and rename it as the blue saber. But we need the two materials, red and blue as well. So I'm going to duplicate this material 2 times and I'm going to rename them as red and I'm going to rename the other one as blue. And then I have to change the color of these materials as well. So just pick a blue color, and I want some kind of glow coming out of my saber, some kind of emission. So I'm going to select this option that says emission. I'm going to use the eyedropper tool to select the blue and increase the intensity by 1. Same goes for the red material as well. I'm going to select the red color, turn on emission, use the eyedropper tool to select red again, and increase the intensity by 1. Now I can simply place these materials into the sabers. But there is still something left. To attach these sabers as your controllers, you need to pass them into the XR controller right here as a model prefab. To store these sabers as a model prefab, simply drag them to the Asset tab, and then you can even delete them from the hierarchy. For the left hand, I'm passing in the red saber, and for the right hand, I'm passing in the blue saber. Now we can try running this application on our VR headset. So plug in your headset, make sure that it is in the link mode, and click on this run button. As you can see on the game screen, which I can even maximize, that I have my two sabers, which are my two controllers, like so. I just need some boxes that will come at me from here, and then I'll have to write some code that will allow me to use these sabers to cut those boxes or to destroy those boxes. Now to create the box, the cube that we will cut, we're going to create another cube. First, let's minimize this game screen. Let's go into hierarchy and create a new object called the cube. And we are going to rescale this cube to make it small enough so that it doesn't look bad, and big enough so that we are able to cut it using our saber. So use the values like 0.5, 0.5, and 0.5. And we need the arrow. As in Beat Saber, there is a pointer which explains us which side to cut the cube from. So we can create that by creating another cube inside this cube as its child. We're going to rescale it by pressing R. Let's give it a color so that it is clearly visible. We can even create an arrow by duplicating this cube 2 times and scaling it down even more. Somewhat like that. So now I'm going to call it as, let's just call it red, and then duplicate it and call it blue. Now we need to change the color of blues by dragging in the material to all of the 3 child cubes. Okay, we have our sabers and we even have our cubes. So what's left? Our cube looks stationary. We need to move it. So let's write some script to move this cube forward automatically. So for that, click on both the cubes, the red and blue, and click on add component, and from here write a new script. Let's call it as cube. Create and add. Now that our script is added, we can edit the script by clicking or by double clicking on it. Now this should open up in your Visual Studio. But if any case it doesn't open up in Visual Studio, or the Visual Studio does not pick up the Unity project or the project dependencies, you have to go to Edit, Preferences, and inside the preferences, you have to head over to the external tools tab, and from here you have to select the external script editor. By doing this, the Visual Studio would automatically pick up the Unity dependencies required to edit its script. We can close this and head back to our Visual Studio. What do we want? We want this cube to move forward every time the screen refreshes, which means that we'll be using this update function. We're going to write some code to transform this cube or to transform its position. We are going to add to its position time dot delta time, and we're going to move it forward by 2 pixels or 2 blocks. This should move our cube forward or cubes forward. Let's check. Okay, as you can see, our cubes are actually moving forward in a straight line, which is actually good. So next up, we need these cubes to randomly generate and have faces in different directions as well. So for that, we're going to move these cubes into prefabs or model prefab, and we're going to delete them from the hierarchy. So what do we need? We need something that would keep invoking our cubes after a specific time has passed. So we're going to create a new empty game object. We're going to call this spawner. You can call this whatever you want, but I'll just call it spawner. First position it to 0, 0, 0 with our camera. And then move it to the end of the platform. I forgot to turn off the run mode, so I'll have to just quickly move these two to prefabs, which are already there. So I'll just delete them from the hierarchy. And I'm going to create an empty game object, place it at 0, 0, 0, call this game object a spawner. I called it a spammer. Spammer is actually a good name as well. So I'm going to move it to the end of the platform. And I'm going to flip it around by 180 degrees so that it faces our player. I'm going to move it up a little bit as well. Okay, so we need to write some code that would instantiate these cubes, and the script of moving forward would also run on every cube. So now we are going to add a script component. So let's call a script, call it spammer, create an add. Open up the script by double clicking on its name. So what do we need? We need 2 arrays. One would contain our cubes, the red cube and the blue cube, and the other array that would store the point from which those cubes are transformed or their position is moved forward. Or we can even say the point from where they are instantiated. So let's create a game object array named cubes and point and a transform array, not tracked reference, transform array named points. We also need some kind of tempo because Beat Saber is actually dependent on the tempo of the song that is being played in the background. So let's create a variable that will store the beats or the tempo of the song. By default, I'm going to give it a value of, let's say, 60 by 120 or 130 multiplied by 2. Then we need something to count the interval between those two beats or the tempo. For that, we're going to create a private variable of float type named timer. So, what to do on every frame? So, first of all, we're going to check if our timer is lower than the beat timer. Then we are going to create a new game object named cube that would instantiate from the array cubes by randomly choosing them either blue or red at points which are also randomly chosen from the array of the points. What is this? I misplaced the brackets. It's not round brackets, it's actually square brackets. This is not beat, it's actually tempo. Okay. Now that our cube has been instantiated, we want it to transform from its local position on to the vector 3, which is the z-axis, to the 0 point. Next up, we want the face of the cube to be random. Sometimes we want to hit it from the top, sometimes we want to hit it from the right, sometimes we want to hit it from the bottom. So for that, we're going to write this line dot rotate now that we have some cubes that are being randomly generated facing random directions. We just have to subtract the tempo from the local time. And then outside of the if statement, we have to set the timer to the current delta time. Okay, so we have our spammer script as well. So what do we need now? We need some cubes and we need some points. We do have cubes. We're just gonna simply drag these two cubes, red and blue. Okay. I'm going to lock this screen, select red and blue and drag them into the cubes array. And then we need some points. I'm going to unlock it, create child of the spammer array. And then I'm going to place these children objects or the points actually at different positions. I'm going to move one of them to the right. I'm going to duplicate it, move it to the left, duplicate it again, move it a little up, duplicate it again, and move it to the center and a little down. Oh, down. And then I'm going to pick all of them and move them a little up as well. Because the camera, the VR headset, is not placed at a player's foot, it's placed at its head. So I have to move this whole object to make the cubes cuttable for the player or destroyable for the player. Now I'm going to select all of these children and move them inside the points list. So this should give us some random cubes facing random directions. So let's test it out. Okay, we are having some issues, which is that we haven't given the tempo. So let's give it a tempo. This tempo basically depends on the soundtrack that you're using, but currently I've not imported any soundtrack, so I'll just give it a tempo of, let's say, divide a minute by 105 beats, and multiply it by 2. Save this and run it again. Now, as you can see, we are getting some blocks thrown at us. There's a slight problem. They're literally being thrown at us in a straight line. So we're going to move them apart a little more. So select the first game object, move it to a little right. Like the second object, move it to the little left. Third one, let's move it up, little more up. The fourth one, a little down. Let's check out the placement now. Well, they're still not far off from each other. We're going to spread them even more. Okay, so things are looking pretty good, even though they're actually a little bland, like they don't have any color or anything, but still. But we'll fix that as well. So now we have our cubes spawning and coming at us, even though they're coming at a constant pace, but we can change that. Moreover, we can change the lightning, we can change the bloom, we can change the color gradient. We can do all of this stuff by writing some scripts. But currently, we want to use our sabers to destroy those cubes because that is the purpose of the game. So we want to add a script to the left hand and the right hand controller. We're going to call it saber. Create an ad and edit this script. So what we're going to do is that we're going to use this layers option to create two more layers. We're going to name one of them called red layer and the other one as, or just simply call it red, and the other one as blue. Now that we have saved our layers, we're going to select this object and change its layer to red. It's the blue object, so we're going to change its layer to blue, not red. And we're going to select this option which says just change children as well. Similarly, for red, we are going to select the red layer. Since we have the left saber in the left hand controller, so that is why we are going to select the red layer, and for the right hand controller, it's going to be the blue layer. So what are we going to do? So we are going to mask these sabers with layers, and we are going to check for layer collisions. So for that, select both of the controllers, open up the script, and start writing the code that I am going to use. What do we need first? We need the layer mask. So create a layer mask, call it layer. Now that we have our layer mask and we are storing the previous location of our sabers, we're going to check for collision. We are going to do that under the update function. First of all, we're going to check for the raycast hit. And for that, we need a variable of raycast hit. What we're going to do over here is that we're going to check for collision while we are swinging our sabers, not stationary sabers, while we are actually swinging them to destroy the cubes. For the size of this ray, we're going to select 1. As our sabers in the start, we created them with the length of 1. Now we're going to check if our saber hit the cube from the upper direction. By upper direction, I mean from the top side of the cube, no matter which way the cube is facing or which rotation does the cube have. I know I'm explaining it in a complex way, so just I'm going to break it down to you. This is going to check whether we are hitting the cube in the right direction. And for the right direction, as you know, we created that arrow by using those three child cubes. Upon hitting it from the top side, we want to destroy the object our sabers are hitting. Not our sabers, the object that the sabers are hitting. I actually forgot one thing. I need to change the previous position as well. So outside here, I'm going to change the previous position and set it equal to the new transform position. Okay, everything should work now. So let's test it out. So yeah, as you can see, everything is working perfectly. I'm able. Let me just maximize the game screen so that you can see clearly. As you can see, the cubes are being destroyed on impact. Pardon those noises. That was my desk. But everything is working perfectly. So now we have the basics of the game mechanics down. What do we need to do now? So our game is actually looking pretty bland right now. So let's try to brighten it up by using some colors or color gradients. Let's add some glow, and we need to add the music effect as well. So I actually have this click sound in MP3 format. I'm going to drag it down in my assets, and I'm going to attach this click sound to play whenever I hit the saber to the cube. To do that, I'm going to select both of the controllers. I'm going to add a gig component and add an audio source. And in this audio source, I'm going to drag and place this clip over here, which says audio clip. Now I need to change a script a little more. So I'm going to open up the Saber script. And here I'm going to initialize an audio source variable. I'm going to call it sound collide. And we need to initialize this audio source variable as soon as this script starts for the first time, which means for the first time in this whole tutorial, we're going to write something in this start method. So we're going to simply initialize it by saying sound collide is equals to get component, and inside the arrows we're going to write audio source. Remember, this is a function, so you have to put the round brackets after it and semicolon. Now we have initialized our sound clip, but we have yet to call it and yet to play it. So we're going to do that whenever we hit the cube from the right angle. We're simply going to say the name of the variable dot play. This should make a sound whenever we are actually hitting the cube with our saber. So everything should work and we should get a sound on impact. So let's run the application. Let me just move back a little so you don't have to hear my desk noises. So just click on play button. So I'm going to, as you can hear, that I am getting a sound whenever I destroy a box or a cube. Whenever I hit the wrong box with the wrong saber, It does not make any sound and it does not get destroyed. So our game is actually reaching completion. So what do we need now? Yeah, we need to make it look actually a little more intriguing, I should say. To make it look a little more intriguing, we are going to import another package. So open up the package manager and search for a package called post processing. Install it. Okay, we have installed the post processing, and so what we're going to do next is that we're going to select the main camera and we're going to create a new layer. Uh, Place it anywhere and call it post processing. Open up the main camera and add a new component to it, which is called the post processing layer. Now, the post processing layer takes a post processing volume, and a post processing volume contains a post processing profile. Don't get confused, I'm going to show it to you step by step. But first, for this first component, we need to select the layer on which this whole post processing or the effects will be added. So we created a new layer which was post processing. And since we are using the main camera for viewing our screen, so we need to change the layer of our main camera as well to post processing. Okay, just like I mentioned before, we need a post processing volume as well. So let's add a volume layer as well. So let's add another component which is the post processing volume. And in this post processing volume, we're going to create a new profile. But before we add any effects to the scene, let me just move the camera where I can see them clearly. Okay, go to the camera, go to the post processing volume, come to the profile, click on the add effect button. First of all, we're going to add some bloom. Sometimes to make these effects appear on your screen, you need to press on this button which says is global. So I'm going to turn it on and I'm going to select this option that says all. This would toggle on all of the options that Bloom has to offer. So let's just choose a color. Let's just say I want a greenish tint in my scene. I would increase the intensity to somewhere, drop the threshold. Okay, that's too much green. I'm going to drop the intensity, increase the threshold. Just play around with these settings and find your perfect tone. And after this bloom effect, I'm going to add another effect, which is the color grading. Just like with the bloom effect, click on this option to turn on all the features that the color grading has to offer. But for the mode, I'm going to select neutral. And then I'm going to select a tint of teal color. And I'm going to increase the post exposure a little bit. Make the color a little darker. Just play around with these settings and find the perfect tone for your scene. Okay, I really like this trippy teal color. Okay, what else? What else? We can even add some vignette effect as well. Turn on all the options and just and increase the intensity to, let's say, 3.5 or something around that value. So let's hop inside our Oculus VR and check out the scene. Okay, this teal color is actually not working for us, so we're going to change this color. Stop the scene. Okay, this looks a little more promising. Not really that much promising, but a little more promising. So our sound is being played, our boxes are coming, we're able to cut them, we're able to give some coloring to them. But there is still something missing, which is the soundtrack. So let's try to find a song which is NCS or no copyright strike song, and let's drag it inside the Unity. Okay, so I found a song Fearless by Lost Skies. So I'm just gonna drag it inside the hierarchy. Now this song should start playing as soon as our game is launched. So let's give it a final test and we will be done building our basic, very basic game. So let's just simply click on the run button for the last time, probably for the last time. Okay, I can actually hear the song. Actually, the tempo is actually really slow, so I'm going to increase the tempo a little bit because the song is, I don't think it's on 110 beats. Okay, so I don't like the tempo of this game. I mean, the song is like really fast and the cubes are coming on really slow. So what we can do is we can increase the speed of the cubes by going into the scripts, or we can increase the tempo, which would actually not increase the speed of the cubes but increase the amount of cubes. But we do not want that as well. Anyhow, you can take that as homework. You can mess around with the settings, you can mess around with the scripts, you can mess around with the tempo and create your own variation of this tutorial. The last thing that is left is to build this application as a standalone APK file or installable Android file in the Oculus Quest VR. So, to build this application, we're going to head over to files and go in the build settings. We already have the Android set up. We have already have our Oculus Quest 2. We're just simply going to press on build and run. Okay, so we are going to name it and we are going to give it a name as dummy clone, just to differentiate it from the rest. So all we have to do is wait for the building process to complete, and we will be able to play this application on our Oculus Quest VR without having the need of a PC. Okay, so the build is complete. Now we can actually disconnect our Oculus VR and head inside the normal lobby of the Oculus VR and try to find our application there. So let's go. Okay, so as you can see, we are inside the VR gallery. So we're going to click on the applications, and from the top right hand corner, we're going to select this drop down menu and go and select the option that says unknown sources. In here, you can see that the Oculus VR tutorial, which was the name of our project, is present. Just click on it and start playing. So I'm gonna start playing a little bit, or maybe just destroy a cube or two. We get greeted by a made with Unity. Our sabers are looking good. We have our cubes coming in, so just okay. So that is not all. I mean, we are not satisfied with the Beat Saber clone that we just made. To be honest, it was just like some cubes floating towards us on a song, and we wrote some script that allowed us to cut those cubes. But if you're talking about game development, in virtual reality using the Unity, that is not all. That is not even sufficient. So there are a million other things that we need to learn, or I should say, there are close to infinite things that one must learn to become a game developer in virtual reality. And we cannot cover all of those things in this very short tutorial. But still, we are going to go over some of the key factors or some important stuff that is required for creating a game. Just to give you guys a hint of how to make certain things work. What if you want to make some grabbable objects or you want to interact with some objects that is placed inside the scene? What if you want to get input from the controllers and what if you want to do something based on those inputs? One important thing that is very very important when it comes to game development. What if we want to create a VR friendly user interface? I mean, we want to learn how to create some text that is placed inside our scene, that is placed next to an object, or some warning text that is attached to the screen of the headset. So, those are the things that we're going to go over right now. So, open up the Unity render pipeline scene that we used to get our first display on our headset. As you can see, I have already opened it up. And in the Explorer, under the Assets folder, I'm going to create a new folder and I'm going to call it the new scene. I'm going to head over inside the folder, create a new scene, and going to name it as learning new stuff. Because to be honest, I'll be learning with you as well. Open this scene by double clicking on it. And as you can see, as with every new scene, we get these two things, main camera and directional light. And we don't need them. So we're just going to delete them. We're going to create a new folder inside here or name it as material. Head over inside the material, create a new material. I'm going to name it as black, just like we did for the Beat Saber clone. I'm going to give it a color of black and I'm going to duplicate it by pressing the keys Ctrl plus D. I'm going to name one of them as yellow and one of them as what do we use? Let's use green or let's just use red. For the red one, click on it and select the red color. I like some emission on my materials because they make it pop out much more. So I'm going to turn on emission, use the eyedropper tool. You already know this stuff. And for the yellow, I'm going to select the yellow, somewhat yellow. I'm going to turn on the emission, choose the color. Okay, back to our scene. So let's create some grabbable objects. We need a plane. So let's just head inside the hierarchy. We create a 3D object plane. Remember, when we are getting started with Unity or game development in Unity, it is a good practice to set everything at 000. So I set my plane at position 000. I'm going to drag and drop my black color. We already know how to get a camera, so we're going to head over inside XR and create an XR origin. We're going to transform it at 000 as well. We're going to check which way it is facing and then we're going to create a new cube. 3D object, click on cube, place it at 000. I'm going to use the W key to turn on the transform, reposition it in front of the camera, drag it down a little bit. And there you go. We have our cube and our scene set up. So to make our grabbable objects, we need some objects, obviously. So let's just create a new 3D object and we'll create a sphere this time. I'm going to place it at 000. Head inside my scene, place it over the cube, press the R key and scale it down. Scale it down a little bit more. Give it a color. And let's see. And let's try running this scene in our Oculus headset. Okay, I have my ball, I have my cube, I have my plane. Everything seems to be working. So let's learn how to create this sphere or this yellow ball grabbable. Well, the next step is pretty straightforward, and we have already done it once, which was to create the left and the right hand controllers and give it some model prefab. So let's do that now. So right click on the camera offset and create an empty game object. I'm going to name it as the left hand. I'm going to duplicate it and rename it as the right hand. Okay, so select both of them and click on the add component and add the XR controller device based. Okay, so what now we need our model prefab. So let's create another empty cube. Let's scale it down to 0.05, 0.05 and 0.15. And I'm going to transform it at 0, 0, 0. And we need to give it some color. I'm going to create a new material. I'm going to rename it as white. And I'm going to choose the white color. Drag and drop this white over here. Okay, we need to convert it into model prefab. So just drag it down to our assets folder or to the explorer. And we can delete it from our hierarchy. Now, inside the left hand, change this controller node to left hand, and for the model prefab, drag our cube inside it. And for the right hand, our controller node is already at the right hand, and we're going to do the same exact thing, dragging our model into this model prefab. Now we should have our controllers working, so let's test them out. So now as you can see, we have our controllers working. This is not something new because we have already done it once. So let's move on to making this sphere grabbable. Okay, so click on the sphere and we need to add a new script on it which is the XR grab interactable. This script would tell the Unity or the game engine that this object is grabbable. Once we have added this grab interactor, we need to select both of our hands, the left and the right hand. We're going to add a new component which is the XR direct interactor. And after we have added an interactor, we need to add some collider space. To use the collider space, we need to add a new component which is the sphere collider. And inside the sphere collider, we're going to reduce the radius to 0.2 or anything that you want. But to make it collidable or interactable, we need to set it to is trigger. Now everything should work fine, and this should let us grab the sphere with our controllers. So let's test it out. As you can see, we are able to grab it and we are even able to change our hands. We can now, like, this ball has some physics attributes to it as well, so we can even throw it. And this ball will keep rolling until it is stopped by some external force. So that is how you create some interactable or grabbable objects. Okay, the next step is to create some user interface. No interface is complete without some text or some text that tells the player what to do, some text attached to an object saying grab me or throw me or whatever you want to do. But when it comes to creating text for virtual reality, we need to take some things into consideration. Either we want to display that text only on the computer screen and not inside the headset, or we want to attach that text to the screen of the headset to make it look like a warning or something that a player must do, or we want to add text inside the screen. Well, we are going to go over all three of those. So, first things first, how do you even create a text in Unity? Well, that is pretty simple. To create a text in Unity, you need to create a canvas. So, just simply right click in the hierarchy and go over to UI and create a canvas. Okay, to view this canvas, simply select on this option that says 2D button. Okay, now this is our canvas. This is where we can add our text or buttons or interactable objects as well. So for now, let's simply add a text and let's see how it behaves with different options. To create a text inside this canvas, simply right click on this canvas, go over to UI and simply select text. This would create a text as a child of this canvas object. To make everything very simple, I'm simply going to select this and set it to stretch all over. And then I'm going to remove paddings from all sides. I'm going to write I am, okay, my bad. I am the UI. And I'm going to increase the size by scaling it up. But it is still not centered, so I'm just going to center it up, increase it even more. Okay, looks good. But I want this text to be inside our frame. There is one thing that we need to focus on right now, that is the render mode. The current render mode is set to screen space overlay. So if you try running this on our Oculus headset, as you can see on the play screen, I am getting the text on the screen, but in reality, this text is not being displayed inside my headset. Well, this option is really useful if you want to create some PC tethered games and you want to display something only on the PC screen and not inside the VR. So that is why we use the system space, or sorry, my bad, screen space overlay. The screen space render mode places UI elements on the screen rendered on top of the scene. If the screen is resized or changes resolution, the canvas will automatically change size to match this change as well. So that was the screen space overlay. So we have another render mode which is the screen space camera. To use this particular render mode, we need to drag the main camera inside this render camera option and we can hit play. Now there is something pretty exciting about this as well. If I put on my headset, I can see the text inside my headset as well as on the laptop screen. But there is only one difference. It seems like the text is slammed against my VR headset screen. This is highly useful if you want to create some warnings for the user, or if you want to create some like press this to continue and press that to continue, that kind of annotation. Okay, we want some text that is displayed as a game object of the scene. Well, to use that, we're going to change the render mode to world space. We're going to shift back to our 3D view. We're going to open up our plane, select the canvas, and resize it. And after I've transformed it, I'm going to resize it once again. And I'm going to place it right next to my sphere, or right next to my yellow ball. I'm going to resize it even more. I'm going to rotate it a little bit and turn it up as well. And inside the text, I'm going to change its color by clicking on this color option and setting it to something like green or blue. Now let's try this out in our VR headset. As you can see, we can see our text right next to the sphere. This text looks good. It looks like a user interface that is telling me to do stuff, although it just says I am the UI. But we can attach it to prompt the user to do something. We can attach it to the sphere, I mean. To do that, first of all, I'm going to close off my play. To do that, I'm going to select the text. And first of all, I'm going to change the text inside it. I'm going to make it say, grab me. And then I'm going to cancel out its rotation. Now, to make this text attached to this sphere, we simply need to drag it as a child of this sphere. Now, this should allow us to move this text when we move this ball. So let's test it out once more. Okay, as you can see, the text is moving along with the ball. I can rotate it. Let's see what happens if I throw the ball. Okay, that looks kind of funny though, not gonna lie. So that is how we can create some text that is attached to the objects of the scene. Similarly, we can even create some buttons on the canvas, but for that we're going to create a new canvas. We are going to change the render mode to world space. And inside this canvas, we're going to create a button. So now we want to resize this canvas. I'm going to reduce its size. I'm going to move this button inside my scene by placing it right next to the sphere. Okay, not the button, but the canvas. And for the button, I'm going to resize it a little bit. Next step, to change the text of this button, I'm going to open up its child, click on text and change it like click me. And that is it. Our button should be working. Although we have not written any script for it right now, we can write scripts to create some new spheres. We can write script to do something. We can write script to start up the game. We can do whatever we want with scripts. But I just wanted to show you how to create a button that is placed inside the scene and not on your screen. I'm just going to put on my headset and one. Now I can write some code to use my controllers or the rays from the controllers to click on that button as well. But that is an advanced level topic that we will discuss maybe in the future. Okay, moving on to the next section, which is to get input from the controllers and how to manage those input and display it on the console. Before we actually start writing code to how to get those inputs or how to manage those inputs, we should know that there's a particular situation that we are facing right now. And that is whenever we are developing a game or an application for the virtual reality headset, we don't know what type of headset does the user have. I mean, you could have a VR, Oculus Quest VR, or HTC Vive or Windows Mixed Reality headset. We don't know what kind of controller he's going to use. Well, lucky for us, the XR interaction toolkit actually gives us a particular key or a particular variable that we can use to access all of those controllers. What I'm trying to say is we have the primary button on every controller, on the HTC Vive as well, on the Oculus Quest controllers, on the Oculus Rift controllers as well. But each controller or each company has its own different conventions. So the XR interaction toolkits actually put these buttons from different controllers under the same name. So that is why the XR interaction toolkit is considered to be one of the best, if not the best, interaction toolkits for Unity to interact with multiple VR headsets. So, before we actually dive inside mapping those inputs from the controllers to be displayed on the console, let's first analyze the controllers or the inputs from the controllers. To analyze the inputs from the controllers, click on this window tab, go under analysis, and there will be something called XR interaction debugger. Open this up. As you can see, our interaction debugger is currently empty. Well, that is because we're not playing anything right now. So, to get values inside the interaction debugger, we need to run a current scene. Just like that, as soon as we click on the play button, we get the left hand controller and the right hand controllers. Wait for a second and then you'll see all the values coming in from these controllers. Like if I was to pick up my right controller and press a button on my right controller, then focus over here on these values would change. If I was to press the primary button, the value of the primary button would change to true. Similarly, if I was to press on the trigger button, the value of the trigger button would change to true. It is a good practice to actually play with your controller and get familiar with the names which are written over here so that you know what button you want to listen for or what particular name you want to listen it for. So I'm just gonna close this down. Okay. Now the next step is to create hand presence or a script that would take inputs from these controllers. So we're going to create an empty game object. We're going to name it as input script. or hand presence script, whatever you want to call it. I'm going to add another component which is going to be the hand presence. Obviously, this is not a component, this is a script that we are going to write. So press on the new script and create an add script. We have a script over here and we need to type something. Normally, it should open up right away, but if it does not, then simply double click on this button or this script name. Open this script in VS Studio Code. We use these kinds of scripts in the Beat Saber clone as well, and we are familiar that there are two functions in each Unity script. The first function is the start function, which is executed automatically every time this object which contains this script is instantiated or created. And then we have the update function. This function is executed once per frame. If you have a programming background, then this should become very clear for you that we are going to initialize our variables, and we're going to initialize our list, and we're going to initialize the values that we are going to get under this function. And then we're going to mimic an event listener under this function that would listen for a particular key. Okay, to get started, we need to import another library which is the Unity engine.xr. Okay, next we need a variable that we will use to store the list of all the devices that are connected to our VR headset. And for that, we need a list of, or the variable of a type list. And this list will be of the type input device. For the name of the device, I'm going to call it devices. And like any other list, we need to call its constructor. If you are not familiar with programming or if you don't know what a constructor is, then worry not, you just follow along with my steps and you'll get to know how these things work. Okay, so now that we have our variable which we will use to store all the list of the devices, we need to populate this list. To populate this list, we're going to use a function which is input devices dot get devices. Now this function takes a variable of the type list which we have already created, which is the devices. Okay, so next up we have to iterate through this list, and maybe we just want to display what are the devices that are connected to our VR headset on the console. So we can do that by using a for each loop, and I'm going to rename this with devices. We can write to the console using this function which is the debug.log. We are using the variable item to iterate in between the a list of devices and the characteristics. So if we write item dot, you'll see a bunch of options that are available, or the bunch of values that are available as well. We have the characteristics, whether it will tell us it is the right hand controller, it has the controller characteristics, it has the motion characteristics, or some other characteristics for some other VR headset. Basically, this variable will tell us all the characteristics of a particular device. May it be the headset, may it be the controller. So let's just try to simply output the name and the characteristics onto the console. So we do that by item.name plus item.characteristics. So we are going to close this and let the Unity save this script, and let's open up our console. To open up the console, go over to Windows, go over to General, and go over to Console. Run the program, and we have actually detected the head device, but not our controllers. So let me see. I think they were just on like standby mode, so that is why they're not showing. So I'm going to play it again once more. And we should get our controllers. So open up the console. My controllers were actually on standby, so that is why they didn't show up for the first time. But now, since I've moved them and have played with them a little, they are showing up. So this is the thing. We are showing that we have the name, which is the Oculus Quest 2 head mounted. And then we have the characteristic. The characteristic of the head mount is tracked device. Similarly, we have the Oculus Touch controller left hand in held, and the characteristic is as track device, controller, and left. So now that we are able to detect the controllers, or my bad, the detect the devices that are connected to the VR headset, we can now check for particular key presses. First of all, stop the run. Let's first try to filter out the devices based upon their characteristics, and then we're going to use their characteristics to listen for a particular key on that particular device. I know it sounds a little complicated, but in reality, it is not complicated at all. So, what do we need to do? Yeah, we need to open up the script and we need to make changes to it. Okay, so in the script, so the first thing that we need to do is create a variable that will actually tell our compiler that this is the characteristic that I want to look for. So I'm going to remove this line and I'm going to create an input device characteristic variable. And I'm going to call it right hand. My bad, I need to follow the convention. So the right hand controller characteristics or just character, whatever. I'm going to set it equal to some particular characteristics which are going to be input device characteristics dot right. Moreover, I just don't want any right, like any device could have a right characteristic. I want the controller to have the right characteristics. So I'm going to add another characteristic, my bad, by typing in input device characteristic dot controller. Now, how do I know that this is the characteristic for my right hand controller? Well, I don't even need to open up the console once more because I can see it over here. The last entry in the console was for the right hand controller. So we can see the right hand controller had these characteristics: right held in hand, track device, controller, and right. So these last two characteristics are the ones that I'm looking for. Okay. Last time we populated the devices list or this variable right here with all the input devices that were available. But this time I'm only going to populate it with the devices that have these characteristics. So just like the last time, we're going to type input devices dot get device, but rather than get devices, we're going to write or use the get devices with characteristics function. Now, unlike the normal get devices function, which was only taking one argument, this function takes two arguments. The first argument is the characteristics argument, and the second is the same, which is this variable, which is the list of devices. So let's pass in the right hand controller character, and for the second argument, we're going to pass in devices. So, what should happen? So, in the console, we should not get the Oculus head mount, we should not get the left hand controller, we should only see the right hand controller, even though I would be moving my left hand controller and I will be using my head mounted device as well. So just save it, close it up, and run the file. Okay, I'm actually using my left hand controller as well, but I'm going to open up the console, and there you go. We are only looking for the right hand device. Now, you may ask, why is that even useful? Why are we only looking for the right hand device? Well, just to give you guys an example, there is a name for a button called primary button. And this primary button is actually present on both of these controllers, for the left controller as well and for the right controller as well. And there isn't much difference between both of these variable names. So the way we differentiate from the right hand primary button from the left hand primary button is by using these characteristics of the devices. I am going to show you how to actually look for the primary button on the right hand controller as well, just so you know how to work with these things. Okay, open up the skip once more. We already know that this variable devices only contains information about one device, which is the right hand controller. But to use this variable in the update function, we need to initialize it as a global variable, or we can simply create a new variable. We can name it as something target device or input device. So let's do that, like create a new private same data type, which would be input device. We're going to call it target device. And in here, we're going to set the target device equal to the first element of the devices variable list. I mean, we already know there is only one variable. But just to be clear of any errors, we can put this inside a check, an error check. Devices.count is greater than 0, just to clear out any errors. Okay, so we have already created a variable which we can access in the update function. So let's try to access that variable, and we're going to put a dot in front of it. And there is actually a function which is used to listen for a particular key value, which is the try get feature value. So this function, the try get feature value function, actually takes in two parameters. First is the key or the button that we want to listen for, and the second is the value that we want to output. So for example, if we want to listen for the primary button, we can use common usages dot primary. Okay, that's the joystick. Primary button is the one that we want to look for, and we want to output it as the boolean, and we're going to call the output the primary button value. I've written down button, but it's not button, it's button. But how do we know that we are actually getting a value? So we write another if statement. We say if we are getting anything in this value, or if this value is true at any point or at any frame, we print out in the debug log. You pressed the primary button on the right hand controller. By the way, if you want to do something on this particular button press, you will write it under this option or under this if statement. So let's save it up and let's close it. I am going to explain what this out is, what this bool is, and why are we using a boolean variable. But for now, let's just save it and let's run it and let's look at our console. Okay, as you can see, we are already getting that console that we made in the start function. But if I press the primary button on my right hand controller, I should see something on this console. Okay, so I am getting that you press the primary button on the right hand console. If I press it many times, you can see that this number over here is increasing. Okay, there is an interesting feature that is going on over here. I press the button only one time, but I'm getting 5 instances of that button. Why is that so? Well, I'll simply tell you. The update function that we had in our script was running on every frame, and it took me 5 frames to press and release that primary button. So that is why we are getting 5 instances of that print console command. Back to our script once again. Okay, so what does this out means? Why are we using this boolean? Why not some other value? So let me just explain to you guys. This out is actually enabling us to use this primary button value in some other function, like we are using it under the if statement. We are using the boolean variable for a button press, which is like true or false. But we actually get three options here. We get the float value, we get the a boolean value, and we get the vector2 value. So what are these values and why do we use these values? Well, just like we saw right now, that boolean is used to detect a key press for a primary button for the secondary button. The float is used to detect axis values, like for the trigger button. The trigger has values ranging from 0.1 to 1. The vector2 value is used when you want to listen to the joystick, as the joystick has two axes, the y-axis and the x-axis. So I'm actually going to write two more if statements for the float value to show you how the trigger value button works or the trigger axis works, and a vector2 value to listen to the inputs from the joystick on the right hand controller. Okay, so now that we have written down the code for all the variables, I'm going to explain to you what we are doing and why we are doing that. So for the trigger value, we want to listen when we have pressed the trigger button very slightly. So that is why we're using the float zero point 0.1. And for the vector value, we want to listen when the vector is not at 0 or it's not at its origin. That would mean that we are using a joystick. So let's just save it and observe our console. Okay, let me just open up the console window. Okay, first test. We are going to check for a trigger button. We are pressing, I mean, the primary button. For a joystick, okay, I am getting some X and Y values for the joystick as I'm moving them around. And let's check for the trigger button. Okay, you press the trigger with a force of 0.342721125. Okay, so now we know how to check for inputs. Now we know how to check for which type of controller or which are the devices that are connected with the VR headset. We have learned how to make a user interface as well. Okay, so this was a very short tutorial, short in the sense that Unity and game development in VR is actually a very massive field. We have learned how to work around in Unity, how to use different tools in Unity, how to create objects in Unity, how to use materials in Unity. We have learned how to create a simple game in Unity, how to code the game, how to code its objects. We made a simple Beat Saber clone. We learned how to use or how to create user interface for VR and how to look for or listen for the inputs from coming from the devices. But if I were to say that this is a complete tutorial, that would be a complete lie. Because then again, game development in Unity and in VR is a massive field. I mean, some important topics that we still need to cover are like how to teleport the user, how to make the user move using the left hand joystick, or how to access the ray interaction that is provided by the Oculus Quest 2, or how to place in some real world objects, or how to what if we are making a VR shooter and we want to grab a model and we want to work on its animation, like if you're firing a gun, then the barrel of the gun should move back and forth and the bullet should drop out of it. So these are the topics that are very important, which we may cover in the future videos. So keep watching. So that's about it.